So I'm not gonna lie to you, the first lesson of this unit, that 6-0 lesson, all about exponent rules, was kind of a lot. I mean, I don't think the rules alone, like individually, are hard to understand, but when they're all like meshed together, it can get confusing. So if you were not here or you showed up for only like the end of it, just make sure that you're watching the videos. I do like all the examples pretty much from the flip book. If you need a flip book, make sure you ask, because that should be really helpful to you with like looking up the rules and things like that. Today's lesson I do not think is difficult. It's mostly vocabulary, and it's the introduction to polynomials. So that's what this whole unit is about. So polynomials, you'll learn what those are, how to write them in standard form, how to classify them by degree and term, and then, you know, if on your test, I know it'll ask you to list them from least to greatest based on degree. Or list them from least to greatest based on term. So that's something that you'll have to be able to do. So a little bit more like vocab based today. I'm recording right now, and I'll make sure to link it in the slides here like I always do. If you want to check out videos from the past few years that I've given my students, they're also there too if you want them. The practice is a worksheet which you picked up. Personally, I think all the problems are doable, and we have plenty of time to do all the problems, but I already printed them saying evens or odds, so I'll just leave it like that. But I welcome you to do the whole worksheet if you want the extra practice. We should have plenty of time between today and tomorrow. We finished the notes today and even had time to practice. So tomorrow it looks like I'm just going to give you a little more time to practice. We'll look at the answers, you'll do your exit ticket, and move on to the next lesson. So it won't take us the full 2 days. Just make sure, you know, when I give you class time to work, that we're actually working on it. Reminder that the deadline for late work from the blue folders is coming up. So I organize all the work like by color folder. They all have the same deadline. So that is coming up soon. That's February 4th for the late work from the blue folders. And I know some people were absent for an extended time. You're still accountable for the work. Just if you need like an extension on the deadline, I can give you equal to the amount of days that you were absent. So if you were gone 5 days, well, then you can have till February 9th. So you figure that out on your own, like how long you actually have to turn stuff in, and make sure you turn it in through Schoology. So coming up, not this Friday, but next Friday. All right, we'll have an exit ticket tomorrow on the lesson we're learning today. So any questions? All right, so here we're going to take some notes. And starting with what is a polynomial. So the whole unit's about polynomials. You need to know what they are in order to answer questions about them. So polynomials are going to be an expression consisting of many terms. So an expression consisting of many terms. An expression consisting of many terms. And we've talked about terms pretty much all year, but I still have some students that don't know what terms are. So let's give a definition for terms down here. So just fill this in like the free space over here. So what are terms? Like, how do I know how many terms there are in an expression? Like number 1, how many terms are in there? 3. And how do you know that? Like, what are they separated by? In number one, they're separated by addition signs. So what else can they be separated by? Subtraction signs, parentheses, equal signs, what else? Multiplication signs and division signs. I think that covers about all of them. So you know it's a different term because they are separated by operation symbols. So operation, that kind of includes, you know, addition, subtraction, multiplication, division, equal signs. All right. So basically anything that has to be written out, like a plus sign, a parenthesis, whatever it is, that separates your terms. All right, so if they're smushed together, like 3x, they're smushed together, they're still part of the same term. If they put the dot that represents multiplication in between them, like 3 dot x, then there's two separate terms. All right, but if they don't write it out, they're just smushed together, that's the same term. So a polynomial would have many terms. And there's tons of different examples that I can make. I'll just put one example. So we could have 4x squared plus 3xy minus y squared minus 7. All right, how many terms are in the example that I just made? There are 4 terms, right? 4x squared is a term, 3xy is a term, negative y squared is a term, and negative 7 is a term. All right, so always keep the sign that's directly in front of each term. So that's just one of tons of examples I could give you, but that's what polynomials are. They have many terms. You need to be able to write polynomials in what's called standard form. So like on your test, it might say, solve this and write your answer in standard form. So that means that it is written in alphabetical order. So it is written in alphabetical order with the highest exponent first. All right. Standard form means written in alphabetical order with the highest exponent first. So what does alphabetical order mean? Like if I told you to put cat, dog, and fish in alphabetical order, which one would come first? Cat. So like what does alphabetical order mean? So like how they appear in the alphabet is the order that you write them in. Good. So that's what we do with our expressions down here. So if it has an x, so like just x's and y's in the expression, like in my example up here, well, I'm going to look at the ones that have x's first. And if there's multiple terms with x's, then I'm going to rank them with their exponent being higher, written first. All right, so then alphabetical order always trumps highest exponent first. So you'll look at everything that has an A, and then you'll look at everything that has a B and order them that way. So would you say that my example in red is in standard form? So, yeah. Yes. So all the terms with x's are written first, and between the x's, 2 is a higher exponent than 1, so that's why this one's written first. All right, and then any terms with y's in them would go next, and then any constants would go last. So yeah, y squared is a higher exponent than y to the first, but this one has an x in it, so that's why this one goes first. Make sense so far? All right, so then we're gonna practice writing these polynomials in standard form. So number 1, we have 3x plus 1 plus 2x squared. So the only letter that we are dealing with is what? The x. So between the terms that have x's, which one gets written first? 3x or 2x squared?
2x squared.
2x squared, because it has a higher exponent between the ones that have x's. Make sense? And then what would be written next? 3x, and if it's a positive 3x, make sure you put plus 3x. And then the only thing left that remains is 1. So a positive 1, put plus 1. Any constants, so single numbers, go last. Make sense? All right, so let's look at number 3 together. What letters are we dealing with in number 3? W. So look at all the terms that have W's. And out of these 3 terms that have W's, which one gets written first? Good. W to the 3rd power. So out of the ones that are written, this one has a higher exponent. Then what would be written? Good. And then next would be 20. The minus W, and then the plus 28. All right, now let's look at one that has multiple letters in it. So number 5. So look at the letters that we're dealing with. We have A's and B's. What comes first, A or B? A, so look at all the ones that have A's. So first term, second term, and third term have A's. So just between the ones that have A's, which one has a higher exponent on the A? A cubed. So that one will be written first. What will be written next? 5a squared b squared. There's a 2 on the A. And what gets written third? Plus 2ab. All right. Now we can look at anything else that remains. So now we can look at the terms with just b's in them. Because we already sorted out the ones with a's. Since this one's the only one left, write it at the end. Minus 2b cubed. So makes sense. Any questions? All right, so ABC order trumps higher exponent. All right, so yeah, b cubed is a higher exponent than b to the first, but this term has an a, so we tried it before. You guys try 2, 4, and 6. So try those. So number 2, only one variable that we're dealing with. So you always sort through the ones that have letters first. Constants are always written last. And make sure that you keep the symbol that is in front of each term that belongs to that term. So it should be 7k cubed plus k squared minus k plus 64. All right, and then number 4 should be a negative n cubed plus n plus 24. So make sure you keep that negative that's in front of that term. If it's positive, then write it as positive, like a positive 24. All right, number 6. This one was the more challenging one because it has multiple letters. You needed to sort through all the ones that have C's first. So like negative C cubed minus 7C squared D squared. Then D's and then anything else that remains. All right, questions, comments, make sense? All right, so now that you know how to write things in standard form, practice making your answers all in standard form. Because odds are that's the form it wants on your test. So next vocab word. Degree is going to be the highest sum of exponents for any one term. So the highest sum of exponents for any one term. Highest sum of exponents for any one term. So you're going to have to classify polynomials by degree. And this is what I'll kind of do above some of the ones that we already did. So like number 6, if you look at that one, you're going to want to sort through your terms. So you're going to want to like find the degree of each individual term, and whichever one is highest is the degree for the whole polynomial. So like if I look at number 6, any constants like 13 would have a degree of 0 because it doesn't have a variable with an exponent. But if I look at the second term, it has one variable with an exponent of 3. So the degree on that term would be 3. On the third term, what would the degree be? On 5b cubed, what would the degree be? 3. So it's the sum of the exponents on that term. And that one just has d cubed, so 3. And then over here, on the last term, I have c squared d squared. What's the sum of those exponents? 2 plus 2 is 4. So since 4 is higher than 3 or 0, then the degree of number 6 would be 4th degree. And we also have another name for that, but like sometimes on your test it just says 4th degree, things like that. So that's what we'll be doing, is classifying polynomials by degree. Take the sum of the exponents on each individual term, whichever one's higher is the degree of the whole thing. Sometimes they say, you know, that it's a 0 degree polynomial, or a 1st degree polynomial, a 2nd degree polynomial. But sometimes they also use other words, like if it's a 0 degree polynomial, then that is called a constant. All right, the name of it here, and I'll probably give you like one example of each. All right, so a constant like the number 7, that one doesn't have a variable with an exponent there, so it has a degree of 0. If it's a 1st degree, then that means it is also linear. So that would be like 2x, x to the 1st, so it's a 1st degree. 2nd degree would be quadratic. And that's going to be anything with a degree of 2. So an example could be like 3x squared. 3rd degree would be cubic. An example could be x cubed. And then we have quartic. So anything with a degree of 4. So like number 6 They might say it's a fourth degree, or they might say it's quartic. And I've seen both verbiage on your test, so just be able to recognize it. Luckily, you do get to use your notes on practically all tests except for the retake, so just have this handy to you. All right, but that's how you would classify it by degree. You also have to classify it by number of terms. So you guys know how terms separate now, how to count the number of terms in a problem. So if it's just one term, it is monomial. Because mono means one. Two terms would be binomial, like a bicycle. Like a bicycle has two wheels, so binomial has two terms. What do you think 3 terms would be? What prefix means 3? Tri, so it's going to be a trinomial. Like a tricycle has 3 wheels. A trinomial has 3 terms. And then anything with 4 or more terms is going to be a polynomial. Because poly means many. All right, so for 4 or more, it's a polynomial. Sometimes they generalize all of these as polynomials, but really if it has 1 term, it's a monomial. If it's 2 terms, it's a binomial, and so on. All right, so in these examples that I gave you here in blue, those are all monomials. A binomial example could be, it could be really anything, but anything that has 2 terms, like 2x minus 4, 2 terms. Trinomial would have 3 terms, and polynomials for all. Questions? All right then, so let's do some examples. So we're going to classify each thing, so each polynomial, even though they're not all necessarily polynomials. We're classifying each expression by degree and number of terms. So like number 7, it just gives us 6. So what's the degree on this term? Does it have a variable with an exponent? So the degree is, the degree is 0, which makes it a constant. Good. So practice being able to do both, because it will use both on your test. And then how would you classify it by term? How many terms is in there? 1 term. So it's a monomial. So terms are separated by operation symbols. There's no operation symbols. So it's 1 term, monomial. All right, let's look at number 7. To label the overall degree, you need to look at what it is for each term. So what would be the degree of 7p? 1. What would be the degree of the 1? 0. So what's higher, 1 or 0? So my overall degree is 1, which makes it linear. Good. Use your little chart. And then how many terms are in number 9? 2. So that makes this a binomial. Yes. Yes. All right, last one we'll do together, number 11. What's the degree of the polynomial overall? So what's the degree on this term? 3 is the degree on this term. What's the degree on the negative 8? 0. What's higher, 3 or 0? So the overall degree is 3, which makes this cubic. And then how many terms does it have? So this is a binomial. All right, so degree is different from terms. You can have something with a high degree and not that many terms. So look at them separately. Questions about that? All right, you guys try 8, 10, and 12. All right, so what's the overall degree on number 8? What's the exponent on this x? So good, the overall degree is 1. That makes this linear. So be comfortable if it says classify by degree, be able to say either first degree or linear, because you might have both in your answer options. And then classify it by term. Monomial is correct. All right, what's the overall degree of number 10? Good. Which makes this quadratic. You guys don't know what that is yet really, but we'll do a lot of with that towards the end of the semester. And how many terms is this? Trinomial, good. All right, last one in this set. What's the overall degree? 4. And that makes this quartic, and how many terms? Polynomial. What if it had 5 terms? Then what would it be? Still a polynomial. So 4 more terms makes it officially a polynomial. All right, good. One thing I do want to point out is that, yeah, in this example set, all of the degrees were, like the overall degrees happen to fall on the first term. That doesn't necessarily happen all the time. So make sure you look at each term and see what's the highest and then label the overall degree. So I put in an extra example here so you guys like fill this in the free space. So number 13, like I just added this in. 4x squared plus 3xy cubed minus 11. All right, look at each term and label what the degree of that term would be. So what's the degree of 4x squared? 2. And then on the middle term, we have 2 variables involved. We have x and y. So you need to add the sum of the exponents. That's what the definition says for degree. It's the highest sum of exponents for any one term. So I have x to the 1, y cubed. What's the sum of the exponents? 1 plus 3 is 4. We have x to the 1, y cubed. So 1 plus 3 is 4. And then what's the degree of constants? 0. If it doesn't have a variable, it has a degree of 0. And what's higher out of these 3 numbers? So that would make this, you could call it a 4th degree trinomial. Or if they use this verbiage up here, then it is quartic, a quartic trinomial. So just know that it doesn't always fall in the first term. You have to like sort through it and add the sum of the exponents for that one term. Make sense? All right, so now the backside. We're almost finished, don't worry. The backside is kind of like stuff that we've done before. So we are going to be adding and subtracting polynomials together. So we have, and they just use polynomials like generally. But we have like this trinomial being added to this trinomial. Notice they're in parentheses to separate them out. So always like look inside your parentheses. Sometimes you need to combine like terms from the inside. Sometimes you don't. All right, so if you can simplify inside the parentheses, then do it. But like most of the time you can't. But what you should always do, and write this probably somewhere toward the top, is you should always distribute if necessary. All right, always distribute if necessary. There is always a number outside parentheses, even if it's not written. What's that number? A 1. So like in this example, there's a positive 1 outside the set parentheses. Now when I distribute the 1, does it change anything really? No, but it does get rid of the parentheses. And then sometimes it does change stuff, and we'll talk about that in a little bit. But distributing a positive 1 doesn't really change anything. It's still 11x minus x squared plus 13, just without parentheses. All right, what's the number outside of this set of parentheses? Still a positive 1. So we distribute it, doesn't really change much. But we have a positive 2x squared minus 23 minus 5x. All right, that gets rid of the parentheses, so distributing. What usually comes next when we're solving? Combine like terms. All right, and when you're combining like terms, I probably suggest starting with the higher exponent so that your answer can pretty much be written in standard form by the time you're done. All right, so like I would start with the negative x squared. Does that one have a like term that I can combine it with? What is it? And when I combine them, what do I get? Negative 1x squared plus 2x squared. What's negative 1 plus 2? A positive 1. So I have a positive 1x squared. And remember, when you combine like terms, you don't change the variables or exponents. All right, and then I move on to the second highest exponent. So 11x. Does that one have a like term? Yes, what is it? And when I combine them, what do I get? 11x minus 5x. That's a 5, not an 8. And it's positive, so put plus 6x. And then constants always go last. So I have this constant and this constant. What's 13 minus 23? Positive or negative? So put minus 10. All right, and then is it in standard form? So then we are finished. All right, it doesn't equal anything, so I can't like solve it further. That's the farthest I can go. Make sense? All right, now let's do the subtraction example, and you'll see how they're different. So first step is always to do what? Not in solving. So first step is always to do what? Distribute if necessary. So what's the number outside if it's not written? So distribute the 1. Doesn't really change much in the first set. I have 4x squared plus 5x. But what about the second set? What's outside that parentheses? A negative 1. And that does change stuff, because you're multiplying negative 1 by everything inside. What's a negative 1 times 7x? -1 times 3x squared, and -1 times 1. So when you multiply a -1, it changes all the signs inside the parentheses. So that's why you always distribute. Don't skip that step. Don't just drop the parentheses. That's not how it works. That's like the biggest mistake kids make on tests, so don't make that mistake. All right, and then once you've done that, then you can combine like terms. And I would start with the higher exponent first. So it's pretty much written in standard form by the time you're done. So like 4x squared, does that one have a like term? It is -3x squared. When I combine them, what do I get? Just x squared. 4x squared minus 3x squared is just x squared. What about this 5x? Does it have a like term? Yes, the like term is -7x. I combine them and I get -2x. All right, any constants will go last. And I only have 1 this time. So -1. Good there. Any questions? All right, I want you guys to try 14. And 22. So 14 and 22 is what you guys will try. And first step is to always do what? Distribute if necessary. And if there's parentheses, then yeah, it's always necessary. Does it make a difference all the time? No, but sometimes it does. So that's why you just do it. All right, so distribute the one that's outside each set of parentheses. Does it change anything in the first set? No, I get k squared minus 4k plus 7. All right, does it change anything in the second set? When I distribute the +1. Yes, no. It does not change anything. So I get plus k squared plus 9k minus 3. All right, so you distributed. Next step is to combine like terms. Start with like your higher value exponent so that your answer can already be in standard form. So what would I start with then? K squared. So what can combine with k squared, if anything? No, not the 4k. It needs to have the same exact variable to the same exact exponent to be a like term. So this k squared can combine with this k squared. What's k squared plus k squared? It is 2k squared. When you combine like terms, you're adding the coefficients together. So 1 plus 1 is 2. All right. Sometimes I'll tell students so that they don't get confused. Like once you're done combining them, cross them out. If that's helpful to you, then do that. But now look for your second higher exponent. So I would do -4k next. Can anything combine with -4k? Yes, 9k, because they're both k to the first. So what's -4k plus 9k? Positive or negative? So put plus 5k, good. And then any constants go last. So I have a constant of 7 and a constant of -3. What do they combine to give me? Positive or negative? Put +4. Good, any questions? Is it in standard form? So then box that up, that will be the answer. If you got a different one, make sure you fix it. Questions on that one? So let's roll that. All right, so then we're going to look at 22. Because that one has a minus sign in it, and you need practices with subtracting polynomials. So 22. You need to always do what first? Distribute. Distribute. So what's outside the first set of parentheses? A positive 1. So when you distribute it, doesn't change the signs or anything on the first set. What about the second set? What's outside those parentheses? A negative 1, which does change things. You cannot just drop the parentheses. You have to distribute that negative 1. You get negative m squared minus 2m plus 5. So it flips all the signs in the parentheses. Questions about that? All right, once you've distributed, you next do what? Combine like terms. What would I recommend that you start with? 3m squared. What does that combine with? And when it combines, we get good. Next, what would I say that you put? Or look at? So look at the 7m. Does anything combine with that? Negative 2m. And when they combine, what's 7 minus 2? So 5m. All right, lastly, any constants? I have a negative 1 and a positive 5. Make sure you keep the sign that's directly in front of each term. What's a negative 1 plus 5? A positive 4. All right, so then you box that up. It is in standard form, by the way. And any questions about that process? All right, so we have 5 minutes of class time remaining. I don't want you to pack up early. I want you to use that 5 minutes and, work on your practice. So just evens or odds on your practice, but I welcome you to do the whole thing if you want extra practice. We'll also have some time tomorrow before the exit ticket to work on it. So use the class time wisely.